This topic is about finding the equation of the tangent or the equation of the normal to a curve at a given point. This extends to finding coordinates of points given the gradient of the tangent or the gradient of the normal. Okay, just as a reminder, if you know that f of x is equal to x to the power n, then f dash of x, which is the derivative of x, or the gradient function of x, is equal to n times x to the power of n minus 1. So the power drops down to be the coefficient of x, and the power decreases by 1. In a similar way, if you have f of x is equal to ax to the power of n, then the derivative of x, or f dash of x, or the gradient function of x, is equal to a times n times x to the power of n minus 1. So before we go into equation of tangent and normal questions, let's go through some examples of differentiating using this rule, just so you remember the process. So for the first question, I have to write the question in index form. So 3 over x is the same thing as 3x to the power of minus 1, because x is in the denominator and x is obviously x to the power of 1. So now if I differentiate with respect to x, we write dy dx. So remember, the power drops down, x, and then decrease the power by 1, so it becomes minus 2. So it's the same thing as minus 3x to the power of minus 2. If you want to rewrite that in fractional form, it's the same thing as minus 3 over x squared. Okay, so that would be the first one. The second one is y is equal to 1 over 3x, where 3x is in the denominator. That's the same thing as y is equal to 1 over 3 times 1 over x, which can be rewritten as a third x to the power of minus 1, because 1 over x is the same thing as x to the power of minus 1. That means dy dx will be equal to a third times minus 1 x to the power of minus 2, because we decrease the power by 1, which is the same thing as minus a third x to the minus 2. If you want to write it all in fractional form, it's the same thing as minus 1 over 3x squared. Next one, y is equal to 4 over root x. That's the same thing as y is equal to 4 times x to the power of, because root x is in the denominator, it will be minus a half. Now that you've got in index form, dy dx will be equal to 4 times minus a half times x to the power of minus 3 over 2, using the rule. 4 times minus a half is minus 2, x to the power of minus 3 over 2. If you don't want to have it in index form, this is the same thing as minus 2 is in the numerator, x is in the denominator, but because we've got 3 over 2, is x cubed and then square rooted. That's the same thing. The last one, we've got more than one terms, and we've got a fraction as well with 2 terms in the numerator. So the first thing I would do is split up that fraction into 2 parts. So I get 5 over 3 root x plus x over 3 root x plus minus 2 over cube root of x. Okay, so I need to write everything in index form. So the first term is 5 over 3x to the power of negative a half. The second term is x over root x, will just give me root x at the top. So that means it becomes a third, because 3 is in the denominator, x to the power of a half. And the last term is minus 2 cube root of x, can be, because it's in the denominator, the same thing as x to the power of minus a third. Now that I've got in index form, I need to differentiate with respect to x. So I get 5 over 3 times minus a half, x to the power of minus 3 over 2, applying the rule, plus a third times a half, x to the power of minus a half, minus 2 times minus a third, x to the power of minus 4 over 3. All we need to do is simplify, so I end up getting minus 5 over 6, x to the power of minus 3 over 2, plus 1 over 6, x to the minus a half, minus 2 times minus a third is plus 2 over 3, x to the power of minus 4 over 3. And you don't have to simplify anymore. Just leave it in that form, because the other form gets very complicated. Let's now go through some questions on equation of tangents and normals. So go through multiple questions. Please pause obviously as you need to. Okay, so it says find the equation of the tangent at the point x equals 2 on the curve f of x is equal to 2x squared minus 3x plus 4. So remember, if you want to find the equation of the tangent, you need to find the gradient of the tangent, which means we're looking at the gradient function. We have to find the gradient function. So if f of x is equal to 2x squared minus 3x plus 4, then we need to find the gradient function, which is equal to f dash of x. So we need to differentiate with respect to x. So I end up getting 4x minus 3. Okay, so that is the gradient function. We need to find the gradient of the tangent at x equals 2. So I need to work out f dash of 2, which is 4 times 2 take away 3. 8 take away 3 is 5. So this is the gradient of the tangent. Because remember, when we differentiate, we find the gradient function, which tells us the gradient of the tangent to the curve. Okay, now we need to find the corresponding y value. So when x equals 2, f of 2 is equal to 2 times 2 squared minus 3 times 2 plus 4, which is equal to 8 minus 6, 2 plus 4, which is 6. So now what I do know is I know the point that it goes through, the tangent goes through, and I also know the gradient at of the tangent. So I need to substitute m is equal to 5 and x1, y1 is equal to 2, 6, which is the point. At the point x equals 2, y is equal to 6. I need to substitute into y minus y1 is equal to m times x minus x1. So when I do that, I get y minus 6 is equal to 5 times x minus 2. I need to write the answer in the form ax plus by plus c equals 0. So let's expand out the right-hand side. I get 5x minus 10. I like to keep my x positive, so I'm going to move everything to the right-hand side. So I get 5x minus y minus 10 plus 6 is equal to minus 4. So is equal to 0. So that would be my final solution. So if you're trying to find the equation of the tangent, always find the derivative. Okay, next example, find the equation of the normal. Okay, because when we differentiate, we find the equation of the tangent, then that will help us find the equation of the normal. So first we need to find the the gradient of the tangent, yeah? So first thing is differentiate. So when I differentiate 2x squared minus 3x plus 4, I get 4x minus 3. Now the gradient of the tangent at x equals 2. So if I substitute 2 in the derivative of x, so f dash of x, then I get 4 times 2 take away 3, which is equal to 5. Now be careful, this is the gradient of the tangent. We're trying to find the normal. Okay. Don't forget that if you know the tangent, the gradient of the normal is a negative reciprocal of the gradient of the tangent, which means it's going to be minus 1 over 5. Okay, so we know the gradient of the normal now. We need to find the corresponding y value at x equals 2. So at x equals 2, f of x is equal to 2 times 2 squared minus 3 times 2 plus 4, which is 8 minus 6, which is 2. 2 plus 4 is 6. Okay, substitute m is equal to minus 1 over 5, because that's a gradient of the normal, and a point that it goes through is 2, 6, into y minus y1 is equal to m times x minus x1. So I end up getting y minus 6 is equal to minus 1 over 5 x minus 2. If I multiply by 5 on the left-hand side, I get 5y minus 30. So I'm actually multiplying by 5 throughout, is equal to minus x minus 2, which means 5y minus 30 is equal to minus x plus 2. I like my x to be positive, so if I move everything to the left-hand side, I end up getting x plus 5y, negative 30 take away 2 gives me minus 32 is equal to 0. And that would be the end of my work solution. Let's do a few more examples of this before I go through more complicated examples. So find the equation of the tangent to the curve at y equals 2x cubed plus 6x plus 10 at the point minus 1, 2. So because it's y is equal to, I need to find dy dx because I'm trying to find the equation of the tangent. So I get 6x squared plus 6. I need to find the gradient at the point minus 1, 2. So I need to substitute the x value, which is minus 1, into dy dx. So I get 6 times minus 1 squared plus 6, which is 6 plus 6, which is 12. So the gradient of the tangent, this is the gradient of the tangent, remember. Okay, now I've got my point and I've got my tangent, which means I just need to substitute m is equal to 12 and x1, y1 is equal to minus 1, 2 into y minus y1 is equal to m times x minus x1, which gives me y minus 2 is equal to 12 times x plus 1, which means y minus 2 is equal to 12x plus 12, which means y is equal to 12x plus 14. It doesn't ask me to leave it in a certain form, so I can just leave it in any form. I could have just stopped after I substituted numbers in, that would be fine. Okay, second example. So I've got y is equal to, I don't have an index form, so the first thing I would do is put this in index form. So x squared stays the same. I've got plus minus 7 over x squared, so it's the same thing as minus 7. And because x squared is in the denominator, I can write it as the power of minus 2. Okay, now that I've got in the correct form, I can differentiate with respect to x. So I get 2x minus 7 times minus 2 gives me positive 14. X to the power of, decrease the power by 1, so I get minus 3. Because we're trying to find it at the point, tangent at the point 1 minus 6, I need to work out dy dx at the point x equals 1. So substitute x equals 1 into dy dx. So I get 2 times 1 plus 14 times 1 to the power of minus 3, which gives me 2 plus 14, which is 16. I have a point and I have the gradient, so I can substitute m equals 16 into, m equals 16 and x1, y1 is equal to 1 minus 6 into y minus y1 is equal to m times x minus x1, which means I get y plus 6 is equal to 16 times x minus 1, which means I get y plus 6 is equal to 16x minus 16, which means y is equal to 16x minus 22. So these were all equations of the tangent questions. Let's go through some equation of the normal to the curve. So now we're looking at this one. So again, before we can find the gradient of the normal, we need to find the gradient of the tangent. So dy dx is equal to 2x minus 5. So when we differentiate with respect to x, I need to find the gradient of the tangent at the point x equals 6. So I substitute 6 into the expression for dy dx. So I get 2 times 6 take away 5, which is 12 take away 5, which is 7. This is the gradient of the tangent. So remember, the gradient of the normal is equal to negative 1 over gradient of the tangent, which is minus 1 over 7. Substituting m is equal to minus 1 over 7, x1, y1 is equal to 6 into y minus y1 is equal to m times x minus x1. I get y minus 6 is equal to minus 1 over 7 times x minus 6, And because it didn't want it in any form and I've got a fraction involved, I'm not going to do anything more with that. I'm just going to leave it as it is. So that would be my final answer. Let's look at B. So first thing I would do is, again, it's not in index form, so I'd write it in an index form first. X squared stays the same because it's 8 over root x, and root x in the denominator will be x to the power of minus a half. Now that it's in index form, I can differentiate with respect to x. So I get 2x minus 8 times minus a half gives me positive 4, x to the power of minus 3 over 2. Now I want to find the gradient of the tangent first. So dy dx at the x value of 4, because it's 412 there. I get 2 times 4 plus 4 times 4 to the power of minus 3 over 2. The first term is 8. Second term, I need to square root 4, which gives me 2. Then cube it, which gives me 8. But because it's minus, so it's going to be 4 times 1 over 8. That is the same thing as 8 plus a half, which is the same thing as 16 over 2 plus a half, which is 17 over 2. This is the gradient of the tangent. Gradient of normal is equal to minus 1 over the gradient of the tangent, which is negative 1 over 17 over 2, which is equal to negative 2 over 17. Substitute m equals negative 2 over 17, x1, y1 equals 412 into y minus y1 is equal to m times x minus x1. You get y minus 12 is equal to negative 2 over 17, x minus 4. Again, there's a fraction involved. I don't need to put in a particular form, so I can just leave my answer like that. Find the equation of the normals to the curve y equals x plus x cubed at the point 0, 0 and 1, 2, and find the coordinates of the point where these normals meet. Okay, so the first thing I need to do is find the equation of the normal at the point 0, 0. So equation of normal at point 0, 0. Okay, so we need to find dy dx first. So dy dx is equal to 1 plus 3x squared. So dy dx at x equals 0 gives you substitute 0 into this expression, 1 plus 3 times 0 squared, which is equal to 1. Remember, this is the gradient of the tangent, but we're looking for the gradient of the normal. So gradient of normal is a negative reciprocal of the gradient of the tangent, which is equal to minus 1 over 1, which is equal to minus 1. So we've got the point 0, 0. So substitute m equals negative 1 and x1, y1 is equal to 0, 0 into y minus y1 is equal to which ends up giving me y minus 0, which is y, is equal to minus 1 times x minus 0, which is y is equal to minus x. So that is the equation of my normal at the point 0, 0. I need to do the same thing with equation of normal at point 1, 2. Okay, I already know what dy dx is. So it's the same equation that we're looking at. So I need to find the dy dx at x equals 1, which means I get 1 plus 3 times 1 squared, which is equal to 4, which is the gradient of the tangent. This implies the gradient of the normal will be equal to minus a quarter. That means using y minus y1 is equal to m times x minus x1, I end up getting y minus 2 is equal to minus a quarter times x minus 1. Okay, if I multiply through by 4, I get 4y minus 8 is equal to minus x minus 1, which means 4y minus 8 is equal to minus x plus 1, which means if I leave it as negative x is equal to 4y minus 9, it will make it easier for the next step. So that's the equation of my normal at the point 1, 2. It says find the last step and find the coordinates of the point where these normals meet. That means I need to solve it simultaneously. Now because I've got equation 1 here and equation 2 here, and because minus x is the subject of both the formulae, I can equate the left hand side. So solve simultaneously. Last step is solve simultaneously. So I get y is equal to 4y take away 9, which implies 3y is equal to 9, which implies y is equal to 3. If y is equal to 3, by substituting y equals 3 into equation 1, I get x is equal to negative 3. So which means normals meet at negative 3, 3. Next question. The point P with x coordinate half lies on the curve with the equation y equals 2x squared. The normal to the curve at P intersects the curve at point P and Q. Find the coordinates of Q. The first thing I need to know is what the y coordinate of P is. So at P, x is equal to a half and y is equal to 2 times a half squared, which is equal to 2 times a quarter, which is equal to a half, which implies P must be equal to a half as a coordinate. We're trying to find the normal to the curve at P, so the first thing I need to do is find the gradient function, which means differentiate y with respect to x, which gives me 4x. If I want to find the gradient of the normal at the point at P, then I need to substitute x equals half into this, which means 4 times a half, which is equal to 2. This is the gradient of the tangent. So the gradient of the normal is equal to negative 1 over 2, because the negative reciprocal of the tangent. Okay, substituting m is equal to negative a half and x1 y1 is equal to a half into y minus y1 is equal to m times x minus x1. We get y minus a half is equal to minus a half times x minus a half, which means I get y minus a half is equal to minus a half x plus a quarter. If I take everything, if I leave it in terms of y, then y would be equal to minus a half x plus 3/4. Okay, so that's the equation of the normal. Now the equation of the normal to the curve intersects this curve here. It says at point PQ, so I need to solve it simultaneously now. So if I have So that means this is my equation 1 and this is my equation 2. So I'm solving simultaneously. So y is equal to 2x squared and y is equal to minus a half x plus 3/4. Because both of them have y as the subject of the formula, that means I can equate the two. So 2x squared is equal to minus a half x plus 3/4. I take everything to the left hand side, then I get 2x squared plus a half x minus 3/4 equals 0. If I multiply through everything by 4, then I get 8x squared plus 2x minus 3 equals 0. And I can easily factorize this, which gives me 2x minus 1 in one bracket and 4x plus 3 in the other bracket. That one of the solutions will be x is equal to a half, and the other solution will be x is equal to minus 3/4. But x is equal to a half at the point P. So we already know the point P, remember from here. We already know point P. So that means to find Q, we need to, x must be equal to minus the 3/4, yeah? So at Q, it can't be this one because that's P. At Q, x is equal to minus the 3/4 and y would be equal to 2 times minus 3/4 squared, which gives me 9/16 times 2, which is 9/8. So y, which is equal to 9/8. So therefore, Q is equal to minus 3/4, 9/8. Next one. Line L is a tangent to the curve with equation y equals 4x squared plus 1. L cuts the y-axis at 0, minus 8 and has a positive gradient. Find the equation of L in the form y equals mx plus c. So if I do a rough sketch, 4x squared plus 1 will go through there. So quadratic, so it'll look like this. Y is equal to 4x squared plus 1. Somewhere here we have minus 8 and L cuts through this. And then we're trying to find the equation of this line, L. So first thing we do know is L is equal to, y must be equal to mx minus 8 because L cuts the y-axis as 0, minus 8. And it's a positive gradient, so it must be looking on of this type. Now, if it is a tangent, then it must, tangent implies meets curve at one point, which implies discriminant is equal to 0 when combined. So we've got y is equal to 4x squared plus 1, which is the equation of the curve. And you've got y is equal to mx take away 8. So when you combine them, you get 4x squared plus 1 is equal to mx take away 8. Take everything to the left-hand side, you get 4x squared take away mx plus 9 equals 0. So if discriminant is equal to 0, this implies b squared minus 4ac is equal to 0. In this case, your a is equal to 4, your b is equal to minus m, and your c is equal to 9, which means minus m all squared minus 4 times 9 is equal to 0, which means m squared take away 144 is equal to 0, which means m squared is equal to 144. M is plus or minus, plus or minus square root of 144, which is equal to plus or minus 12, but it must be equal to 12 because it's a positive gradient, so m must be equal to 12, which means y is equal to 12x take away 8. Find the coordinates of the point on the curve with the equation y is equal to x cubed minus 8x at which the gradient of the curve is 4. If the gradient of the curve is 4, dy dx is equal to 4. So first thing we need to do is find dy dx. So dy dx is equal to 3x squared minus 8. Both of these together implied that 3x squared minus 8 must be equal to 4, which means 3x squared must be equal to 12, which means x squared must be equal to 4. X must be plus or minus square root of 4, which means x must be plus or minus 2. So now I need to find the corresponding y values because we're trying to find the coordinates of the point. So when x equals 2, y is equal to 2 cubed minus 8 times 2, which is equal to minus 8. So we've got the point 2 minus 8. And when x equals a negative 2, y is equal to negative 2 cubed minus 8 times 2, which is equal to negative 8 minus 8 times minus 2, mistake there. So negative 8 plus 16, which is equal to positive 8, which means we've got the point negative 2, 8. Prove the tangent to the curve y equals x squared at the point p squared has equation y is equal to 2px minus p squared. Okay, so if y is equal to x squared, then dy dx is equal to 2x, and dy dx at x equals p will be 2 times p, which is 2p, which is the gradient of the tangent. So using m equals 2p, x1, y1 is equal to p squared, and y minus y1 is equal to m times x minus x1. We end up getting y minus p squared is equal to 2p times x minus p, which means y minus p squared is equal to 2px minus 2p squared. If I take the negative p squared to the other side, it becomes positive, so I end up getting 2px negative 2p squared plus p squared, which is negative p squared, which is what we wanted. At a point A on the curve y equals 2x squared, the gradient of the normal is equal to 1 over 8. Find the coordinate of A. So gradient of the normal, first we need to find the gradient of the tangent first. So gradient of the tangent, which is dy dx. So first find dy dx. So dy dx is equal to 4x, which is the gradient function for the tangent. That means the gradient of the normal will be equal to negative 1 over 4x. Okay, and now we know the gradient of the normal is equal to 1 over 8. So negative 1 over 4x must be equal to 1 over 8, which means negative 4x must be equal to 8, which means x must be equal to 8 divided by negative 4, which means x is equal to negative 2. When x equals negative 2, y is equal to 2 times negative 2 squared, which is equal to 8, which implies a is equal to negative 2, 8. Okay, now the last question. The curve C has this equation. Find dy dx. So dy dx. Okay, the first thing to know is this term is 8x to the minus 1 in index form. Everything else is already in index form, so we can just apply it. half times 3 times x to the power of 2 minus 9 times 3 over 2 x to the power of a half minus 8 times, so positive 8 times minus 1 times x to minus 2 plus 30 is a constant which differentiates to nothing. And if I simplify, I get 3 over 2x squared minus 27 over 2x to the power of a half minus 8x to the minus 2. Part B. Show that the point 4 minus 8 lies on C. If it lies on C, when we substitute x equals 4 into y is equal to half x cubed minus 9x 3 over 2 plus 8 over x plus 30, what do we end up getting? Y is equal to half times 4 cubed minus 9 times 4 to the power of 3 over 2 plus 8 over 4 plus 30, which is the same thing as half times 4 cubed is 64 minus 9 times square root of 4 is 2, 2 cubed is 8, 8 over 4 is 2 plus 30, half times 6 is 2 is 32, minus 9 times 8 is 72, plus 2 plus 30, which gives us a value of negative 8, which is the y value for minus 8. So 4 minus 8 satisfies equation, therefore lies on C. Last part, find an equation of the normal to C at the point P, giving you answer in the form ax plus by plus c, where a, b, c are integers. Okay, so we've got the point P and we've got the equation of the tangent. Sorry, the gradient of the gradient function, which is gives you the gradient of the tangent. So dy dx at x equals 4 gives you 3 over 2 times 4 squared minus 27 over 2 times 4 to the power of a half minus 8 times 4 to the power of minus 2. 16 times divided by 2 is 8. 8 times 3 is 24. First term gives you 24. Second term, because square root of 4 is 2, the 2's cancel out, so you're left with 27. 8 over 4 squared is 8 over 16, which is minus a half. Okay, so if I simplify that, 24 minus 27 is minus 3. Minus 3 take away a half is minus 3.5, which is equal to minus 7 over 2. So this is the gradient of the tangent. Okay, if the gradient of the tangent is that, then gradient of normal is equal to negative reciprocal of that, negative, so minus 1 over negative 7 over 2, which is equal to 2 over 7. So now using m is equal to 2 over 7 and x1, y1 is equal to 4 minus 8 and y minus y1 is equal to m times x minus x1. I end up getting y plus 8 is equal to 2 over 7 times x minus 4. If I times through by 7, I get 7y plus 56 is equal to 2 times x minus 4, which means 7y plus 56 is equal to 2x minus 8. If I take everything, so the x is positive, I take everything to the right hand side, I get 2x minus 7y. Take minus 8 take away 56 gives me minus 64 equals 0. And that is in the correct form.